Hi, today I will discuss my first impressions of the Dobot Nova 2 robotic arm. It should be a relatively short video where I will go over the installation procedure and I will run a couple of test programs to show some of its capabilities. First I will get the disclaimers out of the way. I was sent a demo unit by a local supplier, Dobot.nu. I did not receive any form of payment for making this video. All of the opinions expressed here are my own and the unit was sent back to the supplier after I finished my testing. The Nova 2 is a serious piece of equipment, weighing in at around 11 kilograms or about 24 pounds. It is mainly targeted at customers looking for an automated solution in retail. It could be used to prepare drinks, food or pick and package items, for example. Of course, nothing is stopping you from using it for other applications. The only limits are your imagination and budget, of course. These are the parts that come with the arm. A control box that is responsible for steering the movements of the arm, and it also takes care of the inputs and outputs for external signals. There's an e-stop, a Wi-Fi dongle, an interface cable for the end effector, and lastly a big power supply that can deliver around 600 watts. Since the arm is quite heavy, it needs to be bolted down to a sturdy work surface. Since I did not feel like drilling 4 holes in my workbench, I decided to mount it to the table of my CNC router, which happens to have the right spacing between the slots in the machine bed. I will not be using the CNC for the rest of the video, it is just acting as a mounting surface here. The arm has some nice artistic design elements that give it a friendly appearance. This also reflects the target audience that will probably not favor a very industrial looking robot. I will quickly go through the connections that need to be made to use the robot arm. A mains cord can be connected to the power supply. It runs on a standard single-phase wall outlet. The output side of the power supply delivers 48 volts DC and is connected to the controller box. A combined power and network cable coming from the robot is also plugged into the controller box. And of course the all-important e-stop. A wireless dongle is provided that will allow you to connect your laptop to the robot arm. You also have the option to make a wired connection through one of the LAN ports. The IP addresses of these LAN ports can be set to automatic or static, depending on your preferences. The control box also has a number of freely programmable analog and digital inputs and outputs, but I will get to that later. For now, these are the basic connections needed to get started working with the robot. A mounting flange at the end of the arm can be used to attach commercially available grippers or an end effector that is made specifically for your application. There's a connection on the side for input and output signals to communicate with the end effector. This is for example used to open or close a gripper. With the demo unit I received a gripper from DH Robotics. This is not included in the standard package because the type of gripper you need is highly dependent on what you're trying to do with the robot. This type is a nice general purpose gripper for smaller parts. I will link to the DH Robotics site below, where all types are listed. A flange mounting plate and cable are provided for mounting it to the robot arm. The clamping force of the gripper can be adjusted from 15 to 50 newtons, with 50 newtons being around 5 kilograms or 11 pounds. This is enough to hold parts weighing up to 1 kilogram, but you can still put your finger in the gripper without getting hurt. Notice the LED on the side of the gripper. There's a built-in detection function for when an object is pulled away from the gripper. This also signals an output of the gripper, so you can include an event like this in your program, for example by sending out an alarm or by trying to pick up the part again. Here's a demonstration of the ability to change the clamping force of the gripper. At the lowest setting of 20%, the clothespin can be grabbed without opening it. At 100%, it will fully open it. Here's a demonstration of movements that can be made with the arm. You have the option to move the joints individually or to move in a Cartesian coordinate system and have the arm take care of all of the joints' movements with some fancy math called inverse kinematics. This becomes especially apparent when you rotate around an axis when the joints are not in line with the X, Y or Z axis. This means that it will have to move multiple joints at the same time. There are 6 joints in the arm, so it is able to move the gripper in any direction. This offers a lot of flexibility. Let's take a look at some of the things you can do with the arm. For example, to have it react to a push button or to an external signal. For this test, I prepared a push button to work with the control box. I connected the cable to a randomly chosen input. This was then included into a program to move the arm. It runs a continuous loop checking the input. When I press the button and the input becomes high, it performs a couple of movements. When I release the button, the arm stops again. The program you're seeing is made in the Blockly environment of the included software. This is an extremely user-friendly yet powerful method for programming your robot arm. It has blocks for loops, if statements, math functions, custom variables, I/O handling, various movement types, and also things like network communication. There's also a nice integration of grippers from third parties, like the DA's robotics gripper that I have installed. After selecting it in the software, all available commands for the gripper are included in the Blockly environment, so it can be used in your program. Depending on your needs and preferences, you can program the robot in either this visually oriented method or with a Python script. Personally, I like the Blockly environment, and I think that this includes most, if not all, functions that are available to you. For doing some pick-and-place exercises with the Nova 2, I chose these end mill boxes, which can easily be manipulated with the gripper. To show the additional freedom of movement that you get with 6 joints, I printed both a vertical holder as well as a holder at a randomly selected angle. You can align the coordinate system of the holders with that of the robot arm, but it is also possible to create a new coordinate system based on how they're oriented. In order to pick and place products, you have to tell the robot where they are located. The easiest way to do this is by moving the arm manually to each pick and place location and to store it into a variable. I created variables for where to pick up the parts and some safe intermediate locations that can be used to avoid crashing into the holders. After you've saved the location, the variable containing its coordinates will become available for use in your programs. The program I made uses some logic that allows me to transfer the entire row of parts by incrementally moving sideways for each new part. If you want to, you could also use the built-in palette option for this. Besides using specified coordinates to move the arm, it's also possible to create some more natural movements. When you press the Teach button, all motors go into a different mode where the arm can be moved by hand. It will hold the arm just enough to compensate for gravity and will generate some resistance against movement. This resistance can be customized, by the way. In this mode, you can move the arm along any trajectory. All of the movements that you make are stored in a path, which can then be used in any of your programs. So you can easily combine this with other movements or any of the other available functions in the programming environment. Here I held the GoPro in the gripper and manually moved the arm to create a path for the camera to follow. Please ignore my videography skills, but I still hope that this brings across the potential of this function. By following a predetermined path, you can get very smooth motion, which can be repeated over and over again. This can be nice for adding visual effects, like creating a stop-motion film where the objects appear in the frame while the camera is moving. Here's another example, in this case with my old Pentax 6.7. Now a quick word about safety. The Nova 2 is a Cobot, which is short for collaborative robot. Cobots are intended to work alongside humans sharing the same space. The Nova 2 has external force sensing capability that will allow it to stop whenever you come into contact with the arm. There are 5 levels that we can choose from for this setting. My unit was configured to setting 2 when I received it, which requires quite a bit of force to stop the arm. However, when I set it to level 5, the highest safety level, it only takes a limited amount of force to make it stop moving. It is good to understand that cobots are not inherently safe. For each application, the user should do their own risk assessment for their specific setup and effector and type of parts being handled. There are machine safety guidelines specifically for working with cobots, so make sure to follow the standards that apply in your country. If your application requires more advanced safety options, Dobot also offers the CR series of cobots with pre-collision detection. In that case, the arm stops even before you make contact with it. So please consider what type of robot is required for what you're trying to do with it. To get an indication of the positional accuracy of the arm, I performed a quick test with the dial gauge. The arm returned to the same position within a margin well below 10 microns. It should be noted though that this is a very limited test in only a couple of orientations, but it seems very promising. Dobot specifies a repeatability of plus or minus 0.05 millimeters, so I would take that number just to be safe in case repeatability is critical in your application. So I hope this video gave you some insight on the capabilities of the Nova 2. Since this is not a full review, I will not do any formal conclusion, but if you have an application for a cobot, I hope this information was useful to determine if it fits your needs. With that, I would like to thank you for watching. Till next time.